Okay, so this is the second half of lesson 6.1. So yesterday we talked about estimating the area under a graph with rectangular approximation. So we talked about MRAM, LRAM, and RRAM, and basically that's just what side of the rectangle are we using the height from. Today we're going to talk about if we take those rectangles and we rotate them around the x-axis, we can form a volume. So if we want to find the volume of a cone with a base radius of 5 and the slant edge defined by y equals -1/2 x plus 5, so that's this line here. Our base radius, see how they're 5 here. So if we took like a rectangle, like we did yesterday, and notice how we're going to use MRAM. If we took that rectangle and we rotated it around the x-axis, so up out of the page and then back behind the page, that would give us a cone that's going to look kind of staggered. So it's going to look, we're going to split this into 10 rectangles. Oops, yesterday I said you would never have to do like more than 8. I guess I lied. So there's our 10. And so if we're using the middle of each of those 10 rectangles, oops, it would kind of look, that one got ugly, whatever. It would kind of look like that. And so the cone itself would be like jagged, but you'd still get a pretty accurate approximation of that volume. Okay, so the first step that we want to do is sketch a picture. I gave us the picture this time, but you guys could draw that line by yourself, but I wanted to help us imagine what the 3D version of this would look like. So you're using the x-axis as the symmetry of the shape, so it's rotating around that x-axis. Then we're going to divide our shape into as many intervals as the question requires. These create cylinders of equal height. So if we think about, here's our rectangle, right? And we think about it's going to rotate around. It's going to turn into cylinders that look kind of like that. So there's our radius. There's our width of the rectangle. So each rectangle is going to have a width, and that's going to become the width of the cylinder. And each rectangle is going to have a height, and the height of the rectangle is going to become the radius of the cylinder. So the volume of each of these cylinders is going to be the area of the face. So we know that that's pi r squared, and then times the width, okay? So usually we see pi r squared h as volume. So this one would be our h in this case, which I know is funny because we already used height, but hopefully you guys get the picture. So this is the area of the circle, and then this is the width of that cylinder, okay? Now we want to identify key values and solve just like we did yesterday. So our radius, notice how our radius is a function of this line. So whatever our x value is at a certain point in that middle of the rectangle, that's going to be our radius, right? So if if we plug our x value in, the y value it's going to spit out, that's going to be our radius. So if we use an x value here, we'd get this specific y value, and that becomes our r, and we'd plug into this equation down here. So y1, or r squared, right, is going to be the function, so -1/2 x plus 5 squared. This is r, and here we are squaring it, right, because this is the y value, y equals this, and we're going to square it. Our a is 0, our b is 10, okay, and then the height, notice how our width is now height, which I know is confusing, is 1, because we're dividing this into 10 rectangles. Then we need to think about what our start and our end points and our steps are so that we can plug it into the sum of the sequence calculator function. So our start, because we're using MRAM, we want to start at 0.5. So that first rectangle goes from 0 to, well, you can't see it. First rectangle goes from 0 to 1. And so our first y coordinate that we care about is the middle of there. So 0.5. The last one that we care about is in between 9 and 10, so 9.5. And then our step is 1, because there's 1 unit in between each of the middles, okay? So this is going to be pi times h, and then this time our expression is this, so this is our r squared, and so basically we're taking the radius, we're summing it, and then we're taking the radius squared, we're summing it, and then we're multiplying it by the pi h. So we've got the sum of all the radius squares, and we're multiplying by the rest of the function. So sum of the sequence of our expression here is -1/2 x plus 5 squared. X is the variable that we care about. Then our start is 0.5, our end is 9.5, and our step is 1. We plug all that in, and we're going to get 261.44. And because this is a volume, it's going to be a units cubed. Okay, so we used MRAM, so this is the most accurate approximation. If we think back to yesterday, if we used LRAM, we'd get rectangles that are slightly taller than the MRAM, and then our volume would be bigger. If we used RRAM, we would get rectangles that are slightly smaller than our MRAM, and our volume would be slightly smaller. So, one more example, we're going to find the volume of a solid hemisphere. Hemisphere is half of a sphere, with a radius of 5 using MRAM with 10 intervals. Okay, so the first thing that we're going to do is sketch a picture. So we have to think about what our graph is going to have to look like to be able to rotate around the x-axis in order to generate a hemisphere. So the first thing that I draw is my x and y axes. If I have a graph, oops, went a little bit wild, that just looks like a quarter of a circle, and then I took that and I spun it around, it would come up, it would go down, and that would generate half of a circle. It would end up kind of looking like that. Okay, so hopefully you guys can picture, so if I like sliced it down the middle, it would look like that. So it's got a radius of 5, so this would be 5. And then remember that a circle equation is always going to be x squared plus y squared equals r squared. Okay, so we know this from the unit circle, x squared plus y squared. In a unit circle, it equaled 1 because our radius was 1. So this time, it's going to be x squared plus y squared equals 25. And then if we care, so I'm going to leave that for a second. If we think about, okay, if we're splitting this into 10, I don't know if that was actually 10, but close enough. If we split it into 10 and we're using MRAM again, so I'll do this little one, so the middle point is like there. So there's our last rectangle. Okay, we're going to spin that around and it's going to create that little chunk again. Okay, its radius is our y value. Okay, so this point here, that's our y value, right? The radius of that little coin is our y value. So if we isolate this for y, so y squared is equal to 25 minus x squared, y would equal the root of 25 minus x squared. But then if we remember our actual equation for volume, so pi r squared h, we're going to sum the pi r squared h value for each of these little coins, discs, whatever you want to call them. Remember that we want r squared, so we actually don't need that because we're wanting the radius already squared. So we can just plug this in to our calculators as our function. So r squared is y squared, so it's just 25 minus x squared. A is going to be 0, B is going to be 5, and then our height, the width of each of these chunks, is going to be that divided by 10, so 0.5. Our upper and lower boundaries, because we're using the middle spot, so if our first rectangle starts at 0, goes to 0.5, half of that is 0.25, and then our last one would be 4.75, halfway between 4.5 and 5. And then I forgot a thing for step. Our step this time is 0.5. Your step is basically always whatever your h is. Okay, so we would plug this in. We'd go pi times h times the sum of the sequence of 25 minus x squared. And remember, this time it's already been squared, so we don't have to square that whole thing. With respect to x, we start at 0.25, we go to 0.75, and our step is by 0.5. And then when we do all that, we punch it all into our calculator, we're going to get 274, okay, units cubed. Okay. If we think about this, so as a check, the volume of a sphere is 4/3 pi r cubed. So if we plugged that in, did 4 divided by 3 times pi times 5 cubed, we get 523.5, so whatever, 524 units cubed. So that's a sphere. Divide that by 2, and we get 261. Okay, so we're like decently close there. This one's a little bit over because the like middle, generally when it gets to this steep part, the middle x coordinate is definitely higher up and you're getting more volume than you actually need, but still a pretty good approximation. Okay, so now you guys should be able to do, there's not a ton of questions for today, so just page 274 again. This is all the same topic in the textbook. Numbers 22, 24, and 25. So not very many, but just a few to try this out. So it's really, really similar to yesterday, but we just have to think about what it does when we revolve around the x-axis. Sometimes in the textbooks, it'll make you revolve around the y-axis. It's really, really similar. But then you're using, you need the line in terms of x. So if you had like a graph like this, you would have to rotate it around this way. That x coordinate is now your radius, right? So there would be your radius, there would be your radius. And then you need to know how many chunks you're dividing this y into. So really similar. I'm sure you guys can figure it out, or if you have any questions, let me know. That was a nice and short one, so go practice all of the 6.1 and let me know if you run into any issues.